After we know the component of Uppaal, and we say that we have three components. The first one is the editor or the modeling language where we model our system. Second part is the simulator where we validate the system. We can see there we see the behavior of the system, the execution of the system, and the third one is the verification. So the first part is modeling language where we describe the system, we draw the system, we model the system. So the first part is modeling language. In modeling language, we model the system as a network of timing automata. So what's the timing automata? Timing actually is a state machine. So what is the state machine? We will learn today in this part. What's the state machine? But timing automata is a state machine or infinite state machine with variables. So we model the system in Uppaal using timing automata, which is use some variables or clocks to control the execution of time of the system. So in Uppaal, in order to model the system in Uppaal, we should to learn what's the time automata, or in cut we can say is automata only. So in order to understand the time automata, we should to understand the state machine. So as we say today, we continue our class just to learn the infinite state machine, which is we can see the basic of modeling the automata and Uppaal. So let's start with infinite state machine. So what's the infinite state machine? Actually, state machine from the name, it's a graphical presentation to describe the system. But here we describe it as a state, of the system. If we recap the use cases, in the use cases diagram, we describe the system as a component. But here in the state machine, we describe the system as a state. So what's the state, what the situation of the system in certain times? The current state, the next state, the state of the system when the user do some actions. So the system here, we consider the system as a state. So as we say, is a graphical containing a finite set of nodes or location. It's called is state. So we have a finite state machine. It's just a graphical presentation containing a finite set of node or a finite set of state. So in this, for example, this is finite this is a state machine. We have two state, the first state, and we have the relation between them, or we can say is the transition of these between these two states. So here another example of the state machine. Yes, we have this is state machine. We have in this state machine we have three state, S1, S2 and S3, and in order to move from this state to another state, we should have some input. So this is the input, or we can say is the transition from one state to another state. So if the input was zero, we'll move to S2. But if the input 1, so we keep staying in S1. And here is the same. If the input is 0, so we'll back to S1. But if 1, we can go to the last finite state. Okay, here actually we have in the the state in this state machine, we have the initial state where the arrow is starting here, and we have the terminate state. The terminate state is the last one, which we can see is double circle, double line. So the elements of the finite state machine is the state and transition. The state and the transition. The state is the state of the system. The transition is the input to transfer or to move from one state to another state. So what's the example of the state? For example, if we have a system for opening the door, so we can see the state of the system is now, for example, the door is opening, the door is closed, like this. So this is the state of the system. So here we continue with the elements of the state machine. As we see, the first one is what was the main components of the system of the state machine is the state. So the state here describe the status of the system. So for example, if we have the car, so the car is running. So the state of this car is running. Or another state is the car is off or the car is stopping, like this. Or if we have the door, here we can say the state of the door is opening, the state of the door is closed. So this is the state. The first element is the state. The second element is the input. The inputs. So the input is the relation between the states. The input is the action that can change the state of the system from state to another state. So for example, if the door is closed and there is any signal is coming as an input, so the state of the door is changed from closed to open. There are also entry and exit action, and this is associated with the state. So the entry exit or the entry action is performed when entering the state, while the exit action is performed when exit from the state. We don't have here exit action, we have only entry action. So once we move from close to open, so once we enter to this state, we should to open the door. So we have now these two main elements. The first one is the state and the second one is the input. So while the others is the action, it's something to done or to perform when entering this state. Here an example of the finite state automata or finite state machine. The example here is the Turnstile machine. Based on the description of the example or based on our understanding of this machine, the machine has two states, lock and unlock, and the input of this machine that change the state of the machine, it's either push or put the coins. So in this machine we have two input. The input can be just put the coins or push the arms. If you push the arms but you not put the coins, so you will stay in locked state. So as we say, we have these two machines are two state. The first state is lock and the second one is unlock or open. So once you push the arms, it will not open. So the push it's as input. So once you push but you not insert the coins, it will not open, but you will stay at lock state. But if you put the coins, the system will shift from lock to unlock. And the same things here, from unlock to lock. If we put the coins, we will stay, because it's unlocked, we will stay in the machine because it's unlocked, so we stay in this state. If we push, it will go to back to lock state. So here we represent the system as a state machine. As we say, if you have, this is turnstile machine, this turnstile machine have two state. The first state is lock and the second state is unlock. So the input we have, it's, if you come and push the arms will not open unless you put the coins. So once you put the coins, the machine or the system will shift from the first state, lock state, to unlock state. This is the first example of our state machine or infinite state machine. So we have the other example here. Another example is the symbol, as we say, symbol copy machine. It's a symbol copy machine because we can model this system with more complicated modeling. So in this machine, we just, if the user push start, we will add some, we will start, the machine will start, and then the second state is for adding machine. So the first state, just waiting, nothing to do here. Once we got the first input is start. So once we push start, we will move from waiting state to adding sugar. So here we can add sugar, and then we can deliver we can deliver the coffee, we can deliver the cup, and then back to waiting state. So here we have an exercise. I hope you will submit this exercise by next week. So here, just as we see, also is a simple ATM machine. Only the ATM is not the machine, it's not the bank, just the ATM. So here, if we consider a simple bank example in which the ATM machine allow the customer to withdraw the cash. So here we don't have to consider all the operation that's by the ATM, just withdraw the cash. The system, when the customer insert the ATM card into the card reader, then the response the system prompt for PIN. So we should also consider the PIN and validate the PIN. So in this, how we can use the final state machine, a finite state machine, for modeling this ATM machine. For more understanding for the state machine, the state machine can be used for generating the language or for accepting or rejecting a string of the language. So let's see how we can generate a string of the language from the state machine. So see the first example here. In this example, we have two strings, S1, S0, and S1. So the first state, so in the first state, we have only one option. It's as an input, which is A. So to move from S0 to S1, the input should be A. So, and then P, then A, then P. So the string can be generated by this language or by this machine. It's the repetition of AP, the repetition of AP together. So here an example, it's AP, AP, AP. So here's in the first example, so the string is AP, since we have only one option for each from each string, from each state. The second example here, we have S0 and S2 the same, but we have more than one options here. So if we are in S0, we can go for A, 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 or P. But once we go for P, we can take only P, P, P. So this language can generate repetition of A and then repetition of P, not repetition of AP. So the language can be generated from this, or the string can be generated from this. It's A, repetition of A, and repetition of P. In the third example here, we have a we have three 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 state. So we start from the first state machine, from the state, and then if we start from here, we have two options, A or C. So once we take A, we cannot go to C, so we have A and then B, P, 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 and then A. So we can go for A and then repetition of P and then back to A. And then we can stop here, or we can continue C and then repetition of P and then C. So the language here, it's A starting with A or starting with C, and then repetition of P in the two options, repetition of P and then end with C, or collection of these two string. So example is A and the repetition of P and then A, or C, repetition of P and then C, or mix of these two strings. Here, the second exercise, how or what language can be accepted by this machine, finite state machine. These two example in this exercise. The third exercise, as we call it, CDGM. CDGM, that means we have cabbage, goose, and dog, and this man. M stand for this man. So this man, he want to cross the river, and he has only one boat. So if he take the dog, maybe the dog will eat. If he take the dog, maybe the goose will eat the cabbage. If he leave the dog with goose, maybe the dog will eat the third exercise actually is puzzle, and this is also can be solved by state machine. So see how we can solve this puzzle by state machine. Maybe you'll find this is online, but you should to understand how it's work, how this puzzle work. By next week we will discuss these three exercise. You submit these three exercise we have now in this class, three exercise. I'll put the link, and you should to submit before next class. Thank you for listening, and see you every Monday, inshallah. Stay safe. Assalamu alaikum wa rahmatullahi wa barakatuh.